All right, so the next thing that we're going to do is we're going to say, let's complicate this a little bit by noticing that in the real world, parents can increase their children's future incomes by giving them stuff, right, giving them inheritances, or by improving the children's skills so that the children can earn higher incomes themselves. In other words, we can think of this as investing in physical capital for kids or investing in human capital for kids. So Becker says we've got two kinds of investments. We've got HT, human capital, and we've got our good old-fashioned YT, which is physical capital. Right? Stocks, stuff like this. Furthermore, Becker says there's an important difference between these two types of capital. Human capital becomes less useful the more we invest. In other words, we've got diminishing marginal returns to human capital investment. Because human capital is investing in our children's own skills, the longer you spend in school, the less time you have to earn money with all of your skills. Plus, let's be real, getting a college education is a heck of a lot more useful than, the additional years you spend to get a PhD in terms of earnings, right? So we can say that diminishing returns to human capital constant to YT. Why is that? Because unless you're, Jeff Bezos, whatever your family invests in the stock market isn't going to flood the stock market with so much money that investment returns go down, right? So in particular, we're going to say that the return we get from human capital is going to be some function, f of ht, which let's say looks something like 2z times h to the 1/2. Right, just to pick a function that has diminishing returns. Whereas the money that we're going to invest in YT, we'd say we get some g of YT is just going to be 1 plus r times YT. Right, in other words, every dollar we invest in physical capital gives our kid 1 plus r in additional income. Every dollar we invest in human capital gives a little bit less income to our child than the one we invested before. How much we get depends on that value of z. So what this is going to mean is that now our budget is going to be, we're going to spend our income in 3 ways instead of 2, right? We can spend it on CT, just like before, or on YT, or on HT. And our child's future income is going to be, right, 2z times ht to the 1/2, right? The return on their human capital, plus the return on their physical capital, plus their luck. Okay, so this is already looking like a huge mess, right? This is terrifying. So how are we going to go about trying to figure out what the parent's going to do? How much ought you invest in human capital? How much you ought to invest in physical capital? The way that we can do this, the way that we can simplify this problem considerably, is by saying, let's say that the parent decided how much income they wanted their kid to have in the future, right? They picked a value for IT plus 1. Then all they need to do is figure out what combination of investments in human capital and physical capital is going to get their kid to the desired IT plus 1 as cheaply as possible. Right? Because of the fact that parents don't intrinsically care if their kid gets human capital or physical capital in this model, right? They're going to figure out the way to invest in their kid that gets their kid to the desired income at the lowest cost possible. So this is going to be equivalent in 250 to producer theory, where we say if we're going to want to maximize profits, we know we need to minimize costs, right? Even if we don't know what the optimal choice of IT plus 1 is, we know it's got to be optimal to pick HT and YT in the way that gets us to that IT plus 1 at the lowest cost of current consumption possible. So what we're going to do is we're going to say, let's pick HT and YT, right? Assuming we knew the right amount of IT plus 1, let's pick HT plus YT to minimize HT plus YT so that, right, 2z times HT to the 1/2 plus 1 plus r YT plus ET plus 1 plus mu t plus 1 is greater than or equal to the IT plus 1 that we picked. Right? This is exactly equivalent to saying that we're going to solve a cost minimization problem where we minimize WL plus RK so that, right, F of L and K was greater than or equal to Q. It's exactly the same sort of problem. So how do we solve problems like this? Well, what we're going to do is we're going to figure out our marginal rate of technical substitution. Right? We'll say our MRTS of HT and YT is going to equal DF dHT, in this case DI dHT, right? Over DI dyT. So what's DI dHT? Well, it's going to be the derivative of 2z times ht to the 1/2 with respect to ht, which is going to be 2z times 1/2 ht to the negative 1/2. And what's the derivative of it plus 1 with respect to yt? Lovely and simple. It's just going to be 1 plus r. So our MRTS in terms of ht and yt is just going to be, right, the 2 and the 1/2 cancel. So this is just going to be z over 1 plus r ht to the 1/2. Lovely, lovely, lovely. Okay. So what the heck do I do with an MRTS? Well, the MRTS tells us, right, how much physical capital it takes to replace a little bit of human capital. And so we're going to set our MRTS equal to the relative cost of physical and human capital, which in this case is just going to be 1 over 1, because we're defining h and y, right, as essentially requiring equal amounts of sacrifice to produce 1 unit. So this means we can use this to simply find ht, right? So we can say z over 1 plus r ht to the 1/2 equals 1, ht to the 1/2 equals z over 1 plus r, ht equals z over 1 plus r squared. Awesome. So what's this telling us? This is telling us something really cool. It's telling that it's our optimal choice of human capital depends on z, which we might think of as the returns to education or individual ability or something like this, divided by the interest rate that you can get on physical capital, all squared. What's not here, what's missing from this function here, is anything related to our income. Essentially what this is telling us is our optimal investment in our child's human capital is not going to depend on how wealthy we are. As long as we want to help our child achieve some particular level of income, IT plus 1, as long as that level of income is high enough so that we have an interior solution, so we'll be investing in human capital and physical capital, we'll choose exactly the same amount of human capital, whether this IT plus 1 is really, really huge, or if this IT plus 1 is really, really small. And how about our physical capital? We'll just need to invest in physical capital until we satisfy the rest of this condition, right? So our physical capital investment is just going to be IT plus 1 minus our luck minus our optimal human capital and the rate of return. Right, so we'll find our optimal y by saying that we need to satisfy this equation here. So we'll take, say, 2z times z over 1 plus r squared all to the 1/2 plus 1 plus r y plus e plus mu has to equal it plus 1, right? The target income we want for our kid. The squared and the 1/2 cancels out. So what we're going to get is that yt equal it plus 1 minus et plus 1 minus mu t plus 1 minus our return on human capital, which is going to be 2z squared over 1 plus r, all over 1 plus r squared, sorry, all over 1 plus r. Important point here is this means that the amount that we're going to invest in physical capital is going to increase as we invest in human capital. So what's happening here is essentially that because we've got a decreasing rate of return on human capital, and we've got a constant rate of return on physical capital, we can think about our rates of return like this, right? So this is going to be the amount of physical or human capital, right? This is going to be the rate of return. Our human capital is getting less and less and less productive, whereas our physical capital always has a rate of return of 1 plus r, right? Our human capital has a return of z over h to the 1/2. So once we've invested the right amount in human capital, it's no longer worth it to invest anymore. And as long as we're willing to reach that level of human capital, right, we're going to get there and stop, no matter how much more we want to invest. So this is very much equivalent to when we thought about quasi-linear preferences, if this rings any bells in Econ 250, right, how when you have quasi-linear preferences, you invest in the depreciating good, or you buy the depreciating good up until the point where you're satisfied, then all future income goes to the other good. It's exactly the same idea. Now there's one last problem here, which is what if a parent doesn't want to invest this much in human and physical capital, right? What if their optimal combination of ht and yt was less than z over 1 plus r squared? Well, in that case, if they're not able to borrow money, right, if we don't have access to student loans, we're going to say, essentially, they're going to choose a level of human capital that balances between their preferences for their child's future earnings and their consumption, but they're not going to invest in any physical capital at all. So the last thing I want to leave you with, and I'm going to do this in a little bit of a fuzzy way because it's hard to do mathematically, and we've done so much already, is to close with what our parents' budget constraint is going to look like for future earnings and for current earnings when we're able to invest in human capital. Right? So the child's future income and our family's current consumption. Just like before, the minimum child future income, et plus 1 plus mu t plus 1, our maximum consumption is going to be it. But now we're going to have a little bit of an unusual shape here. Because the first little bit of investment that the parent's going to make in their child is going to be extremely valuable. Because it's going to be human capital, and it's going to have a very, very high rate of return. As they invest more and more and more in human capital, the rate of return falls up until it becomes equal to the rate of return on physical capital, right? So this slope is going to be 1 plus r. And this point here is going to be when they've invested z over 1 plus r squared, right? So it minus z over 1 plus r squared. And the important point about this is that this is going to give us a pretty useful implication, a pretty important implication. That's going to be that the amount that of consumption that a parent has to give up to increase their child's future income is going to be much, much less when the parent's investing very little than it's going to be once the parent's investing a lot. As a consequence of that, we can expect that increasing the income of households, when the households are very, very low income, when they don't have enough income to fully invest in their child's human capital, is going to help their kids more and increase particularly their kids' earnings more than providing income to high-income households. In fact, all we expect to happen when we provide income to high-income households is for them to provide more to their children in the form of inheritances, but not to change their human capital at all. Okay. So I'm going to leave it there for today. I know this has been a whirlwind of math. The goal is going to be to work through some examples to help you get comfortable with this sort of problem solving in class when we talk about this. And then after we've presented this theory, to spend a lecture talking a little bit more detail about the implications and philosophy behind these ideas. So thank you so much for sticking with me. I hope it's been fun. I'm really looking forward to talking to you all about this soon.